All right, so this is our first lesson in pre-calculus, and we're going to talk a lot about slope today. Okay, so there's a lot of things, like a lot of ways that people talk about slope, and kind of the big idea of slope is got to do with a line, and we often talk about slope as rise over run. Or this is called the change in x over the change in y. Delta x, delta y. Or another way that we look at it is we take, wow, Mr. Larson, you screwed that up. Okay, so this should be the change in y over the change in x. Okay, we always put y over x. Rise is our y-axis, run is our x-axis. Or we could do take our y coordinates and subtract them, take our x coordinates and subtract them, okay? So there's lots of different ways that we can kind of look at slope, or that we can kind of talk about slope. And we tend to use the letter M, okay? So slope is like the letter M, and it's rise over run, change in y over change in x, y2 minus y1 over x2 minus x1. And again, these points are, nope, that's not what we wanted to do. These points are coming from like an ordered pair. So again, an ordered pair is something like x1 comma y1 and x2 comma y2. So that's where we'd be getting those from. All right, so you may have to find the slope. So again, let's do an example here. Let's do an example. Let's say that you're given 2 points. Let's say it is -2, 0, and 3, 1. So what I'm going to do is I'm going to put my x coordinate here, my y here, my x2 here, my y2 here. Now, could I have labeled 3 and 1 as x1, y1, and then -2 as x2 and y2 for 0? Yes, I could have. However, you got to be careful. You can't do like x1, y2 in the same ordered pair, okay? So you couldn't say like this is x1, this is y2. No, no, no. Do not do that, okay? You may not get the correct answer. All right, so let's start plugging in some of these equations. I'm gonna use this equation right here, okay? This one. So I'm gonna say y2 is, I should say m equals, because that's my slope. So y2 is 1, y1 is 0, x2 is 3, and x1 is -2. Remember, when you have a subtraction next to a negative sign, it turns into like a super plus. That's what I like to call it. Again, subtracting a negative number. I'm taking away something that is negative. In order to do that, I have to, those negatives, those subtractions cancel out, and it turns into addition. Okay? So my slope in this problem is 1/5. All right, so finding slope is important. We deal with slope quite a bit. Another thing we're going to talk about is called point slope form. So if I were to look at point slope form, again, think about what that's saying. I need a point and I need the slope. So our base kind of form or function is y minus y1 equals mx minus x1, okay? Now note, this y and this x never change, okay? Those are part of, because we only have 1 point and we only have 1 slope. What will change is, again, this is coming from an ordered pair, okay? These are coming from an ordered pair, and depending on the problem, your slope might be different. So let's do an example. And let's say the problem says, find the equation. So find equation of a line that passes through, let's see here, 1, -2, and has slope of, let's say it's got a slope of 3. So I'm going to take what I know. First, I'm going to label my point. Okay, I'm going to call this x1, and this is y1. And then this is my m, my slope. So I'm going to take my equation. I'm going to say y, subtract. My y1 is -2 equals my m, which is 3, and then I have my parentheses. X, take away my x1 coordinate, which is 1. Getting all the colors here, extra fancy. All right. Now, I can simplify some of this. So we kind of touched on it earlier, but when I subtract a negative number, they cancel out and turns into an addition sign. So let's rewrite this as y plus 2 equals 3x subtract 1. Now, I want you to remember the distributive property, where this 3 has to be distributed and multiplied into each term. So I still have y plus 2 on the left side. However, I want to get y equals something. So I'm going to go ahead and say, hey, what's the opposite of adding 2? The opposite of adding 2 is subtracting 2. So y equals 3x. -3, take away 5. -3 plus -2 is -5. I think I gave it away. I accidentally said the answer. Now, this formula is called, slope-intercept form, okay? So let's talk about slope-intercept form. So point-slope form was the one we just did, okay? And now we're going to do slope-intercept, which is y equals mx plus b. And that's the form that we just ended up with right here. And then this one's useful because, again, our slope is still the same. So m is still our slope, but we know, okay, so m is our slope. We know that this is our y-intercept. So however you want to think about it, if you want to think about it as being x is 0, y is b, or if you just want to think about, oh, I know what the y-intercept is. The y-intercept, if I draw a graph, that's where my line crosses my y-axis. Okay, so that would be right here. Say it's 0, 4, for example. Okay. So if you have the y-intercept and you know what the slope is, you are able to plug in to get an equation. So let's just say, determine the slope and y-intercept, then describe the graph. Okay, so let's say that our equation is x plus y equals 2. So I got to decide, do I want it to look like this, or do I want to try to get it to look like this? I guess what would be easier? Now, all that I'm given is this equation. If I had a point, that might be more helpful, but I don't. So I want it to look like this. So I got to think, how can I get y equals mx plus b? And the only way I'm going to get that is if I take x away from my left side and I take x away from my right side. So I'm going to say that y equals 2 subtract x, okay? Now it doesn't quite match this, right? It's a little bit different. Or let's say y equals, I can move this guy to the front and call it negative x. Now this 2 is still positive. There's no negative sign above the 2. So I'm going to say y equals negative x plus 2. So now I have some information, okay? Let's analyze. mx, m, okay? The number in front of m is a negative 1. So my slope is a negative 1, and then my y-intercept is this other number, which is a 2. So again, my ordered pair or my y-intercept, your y-intercept, x is always going to be 0. Because again, if you look at this graph, again, in order to cross that line, x has to be 0. Okay. And the last topic we're going to talk about is parallel and perpendicular. So parallel means that your lines are never, ever going to cross, okay? Never going to cross, and they're going to go on forever. So in order for lines to be parallel, they must have the same slope. So that's like saying rise over run, or the rise over run is the same, or the m is the same. They must have the same slope in order for them to be parallel. Perpendicular is a little different. Perpendicular, okay? Perpendicular is different because they are, I'm going to say, quote, opposite reciprocals. Reciprocals. This is one of those words that I really struggle to spell. Reciprocals. So what does that mean? So reciprocal means flipped. Okay. Opposite means positive turns to negative and negative turns to positive. You can think about it like multiplying by negative 1. If I take 2 and I multiply it by negative 1, okay, 2 times negative 1, it equals negative 2. However, if I take negative 2 and I multiply it by negative 1, negative times a negative equals a positive. So for an example, if my slope was, let's say, 4, okay, my perpendicular slope, so that's this symbol right here. This symbol right here means perpendicular slope. My perpendicular slope, if I flip it, again, any whole number has a denominator of 1. 4 over 1, 2 over 1, negative 10 over 1. Okay, any number can be written divided by 1 because it doesn't change it. So I'm going to call this 1/4, but I need to not forget about this positive to negative, that opposite part, right? So if it was positive, now it's not. That means my perpendicular slope is negative 1/4. And so if we draw two lines that are perpendicular, okay, so let's say that this one had a slope of 4, so this is m equals 4, and then this one had a slope of m equals negative 1/4, they create a right angle. Okay, so where they cross, this is a 90-degree angle, perpendicular. Positive slopes, okay? Positive slopes look something like this. They go up and to the right, whereas negative slopes, something like this, go down to the right. Of course, you know, if it's a line, it's hard to say because yes, the one side goes up, the other side goes down. But I like to just think about it kind of like that, where, hey, if it's a positive slope as I'm going to the right, I should be climbing. And if it's a negative slope and I'm going to the right, I should be going down. All right, hello there. We're going to review some more slope activity. Again, slope is super important in math. Just as a reminder, slope equals rise over run, or it can equal the change in y, over the change in x. We also call it, why is it doing that? We also call it y2 minus y1 over x2 minus x1. But I wanted to talk about some kind of unique cases here. So for starters, I'm going to say, what if you get a line that just says something like y, why is it doing that? Y equals 2. So again, if this is 1, this is 2. If I were to draw y equals 2, notice this turns into a horizontal line. So I have a run. Again, my x is changing, but my y is not moving up or down. So y equals 2 is a horizontal line. We don't have any rise in our equation. Okay? Whereas if, let's say, what if we got an equation that was something, or we got a line that looked like this, okay? Where it's vertical, okay? This has rise, but it has no run. We're not moving left or right. So this line would actually be called x equals -1 because we have no movement right or left. And when we have a vertical line like this, we actually say, again, our run would be 0. So think about it as, okay, I have any number on top, but if I have a 0 in my denominator, we call that undefined, okay? Undefined. So we really can't, if we get a vertical line, we don't say it has a slope of 0, we say it's undefined. Whereas if we get a horizontal line, we can say that has a slope of 0 because you can have a 0 in the numerator, it equals 0. But if you have a 0 in the denominator, it becomes undefined. So those are two kind of unique cases. Again, y equals 2, y equals any number. It's not changing. It's going to be 2 the entire length of the line. Whereas if you get x equals something, x equals -1, x equals 5, okay, that's going to be vertical. And when we have a vertical line, we say it is undefined. Our slope is undefined. Let's draw up a few more, again, unique examples. Let's go right here. So I'm going to say, let's draw y equals 2x, okay? So I'm going to start with my y-intercept is 0, so y equals 2x plus 0. We know you don't necessarily need that. So I'm going to go up 2 over 1. I can go up 2 over 1. Let's move this. Up 2 over 1. And then I could also go down 2 to the left 1. Down 2 to the left 1. And I can create my line this way. Okay. Now, okay, so this is y equals 2x. Now, if I were to draw a line that maybe said y equals -2x, okay? Y equals -2x. So again, my y-intercept is going to be the same. So y equals -2x. But again, my rise is going down because it's negative. So again, if I think about rise over run, okay, -2 is on top and I have 1 on the bottom. So I'm going to go down 2 over 1, down 2 over 1. And then when I'm moving on the other way, I'm going to go up 2 over 1, up 2 over 1. Now, I always like to start at the y-intercept and work from there. Or if you're using point slope form, start with whatever point that they give you. Now, a common misconception would say that these are perpendicular. Remember, perpendicular means that they cross at 90 degrees. That is not true, okay? They do not create a right angle here. Remember, perpendicular slope, okay? Perpendicular slope is the opposite reciprocal. So if I want to look at this one and I see that my m equals 2, my slope is 2, the opposite of 2 is negative 2, and the reciprocal, if I flip it, again, this is 2 over 1, so if I flip it, the opposite reciprocal is going to be negative 1/2. So again, I'm going to be looking at this black line here, and I'm going to start at my y-intercept. I still have, so again, my equation is y equals negative 1/2 x plus 0. My y-intercept is still 0. I'm going to go down 1 over 2. I'm going to go down 1. I'm going to go over 2. I'm going to go up 1 and to the left 2. I'm going to go up 1 and to the left 2. This is my perpendicular line, okay? So this green line is perpendicular to that red line, to that black line, okay? And we can see, hey, here's a right angle, okay? This is a 90-degree angle with that black line. So if I were to make some conclusions, I would say that the black line and the green line are perpendicular to each other. Okay, I would say the black line and the orange line are moving in opposite directions because, again, one slope is positive and one slope is negative, but I cannot say that they are perpendicular to each other. The last kind of example, so we talked about perpendicular, we better talk about parallel real quick. Again, just as a refresher. So if your lines are parallel, okay, so if your lines are parallel, let's just keep y equals 2x. So I start here, up 2 to the right 1, up 2 to the right 1, or I go down 2 to the left 1, down 2 to the left 1. I'm going to put these lines together. Okay. Now, if these are truly going to be parallel, my slope has to be the same, but my y-intercept can be different, okay? So I'm going to create a new line, and I'm going to call it, let's get blue. I'm going to say y equals 2x, but I'm going to say minus 3. So again, my y-intercept is negative 3. So when x is 0, y is negative 3. That's going to be right here. And I'm going to go to the up 2 to the right 1, up 2 to the right 1, up 2 to the right 1, down 2 to the left 1. These lines are parallel to each other. They are never, ever, ever going to touch. They're going to continue on forever and never touch each other. We use a type of symbol like this to show that these two lines are parallel. If you have more than 2, again, if they match, if I have 2 and 2, that means that those lines are parallel to each other. They're like little arrows.